Section 8.3 Products and Quotients in Trigonometric Form. We're going to see how to multiply and how do we divide. We're going to see these two things of two complex numbers that are written in trigonometric forms. And then we're going to see why we need to learn this. That's what are the objectives of this section. So to start with this, those are theorems. We call them the product and quotient of complex number. So the theorem said if Z1 is a complex number given written in a trigonometric form, R1 cosine theta 1 plus I sine theta 1, and Z2 R2 cosine theta 2 plus I sine theta 2. So we have two complex numbers written in trigonometric form. So the theorem said two things. We can multiply them, and it's not difficult to prove when you really want to prove this theorem. You multiply the r's, r1 times r2, and then we add the angles, theta 1 plus theta 2 plus I sine theta 1 plus theta 2. That's for multiplication. For division, z1 over z2, that would be r1 over r2 cosine theta 1 minus theta 2 plus I sine theta 1 minus theta 2. So in the case of multiplication, we multiply the r's and add the angles. In case of division, we divide the r's and then subtract the angles. That's what the theorem said. And to apply it, let's say we're asked to find z1, z2, means z1 times z2, for z1 equals 4 cosine pi over 12 plus I sine pi over 12, and z2 8 times cosine pi over 12 plus I sine pi over 12. Notice theta 1 and theta 2 are the same here, but it doesn't have to be always the same. So to find z1, z2, remember we multiply the r's, this times this, so 4 times 8, and then cosine, add the angles, pi over 12 plus pi over 12 plus I sine pi over 12 plus pi over 12. So now let's see what we get. 4 times this is 32, 4 times 8, cosine. Here we get two copies of pi over 12 plus I sine 2 copies of pi over 12. And that gives us 32 cosine pi over 6 plus I sine pi over 6. Can we simplify more? Yes, we can. What's cosine? Pi over 6 is 30 degrees. Its cosine is the square root of 3 over 2. And this one is 1/2. Then multiply by 32. So that gives us 16 square root of 3 plus 16i. We can also do division. What about z1 divided by z2? To do that, z1 divided by z2, we divide the r's, 4 over 8, and then we subtract the angles, pi over 12 minus pi over 12 plus I sine pi over 12 minus pi over 12. If you want to know where these are coming from, remember this is theta 1, theta 1, theta 2, theta 2. So now, what do we do here? This is 1/2 cosine 0 plus I sine 0. Cosine 0 is 1, I times 0. So that gives us 1/2. Now, as another example, let's say we are asked to use trigonometric form. To find z1, z2 and z1 over z2 if z1 is -2 plus 2i squared root of 3 and z2 is square root of 3 plus I. So we can use trigonometric forms. Yes, you can multiply it out and divide them as we learned before, but here we were asked to find or use trigonometric form. The first thing we need to do is write each one of z1 and z2 in trigonometric form. And how do you do that? We need to find the r and theta for each one of them. So z1, how do you find the r? Let's call it r1, is the square root of, from the previous section, the first one square plus 2 square root of 3 squared, no i's in there. 4 plus 4 times 3, 12. That gives us the square root of 16, which is 4. That's r1. To find theta 1, we do tan inverse of y over x. So it's 2 root 3 over negative 2. And what we get for that? Tan inverse of negative square root of 3. What's the angle? It's tangent negative square root of 3. So first think about no negative. So the square root of 3 is, that's 60. So that's going to be in the second quadrant, 120. Let's do it in degrees. So you see it's not always in radians. So I found r1 and theta. So then z1, r1 is 4 cosine theta 1 plus I sine theta 1. So I was able to write z1 in trigonometric form. I'm going to take z2, which is the square root of 3 plus I. We find r2, which is the square root of 3 square plus 1 square. 3 plus 1, 4. So that's 2. That's r2. And we need to find theta 2, tan inverse of y over x. So that would be, what would that be? The angle is tangent. It's going to be in the first quadrant. That would be 30 degrees. So z2 is written r2 cosine theta 2, which is 30 degrees, plus I sine 30 degrees. So I have z1 and z2 in trigonometric form. Then we can multiply them, z1 times z2, by multiplying the r's first. The r for the first one was 4, and the r for this one is 2. Cosine, add the angles, 120 and 30, plus I sine 120 degrees plus 30 degrees. That gives us 8 cosine 150 plus I sine 150. And what does that give us? Cosine 150 is negative square root of 3 over 2 plus I times sine 150 is 1/2. If you distribute the 8 in, you get negative 4 square root of 3 plus 4i. That's what we get for z1 times z2. And also we can do z1 over z2. We divide the r's, 4 over 2. Cosine, subtract the angles, 120 for the first one and 30 for the other one. Plus I sine, subtract the angles, 120 minus 30. This gives us 2 cosine 90 degrees plus I sine 90 degrees. Cosine 90 is 0, sine 90 is 1. Multiply by 2, you get 2i. So that's what the main theorems that we need here. What else we have to learn? We can learn about what we call complex conjugates. It's applying the same theorems basically to prove this. The theorem said about complex conjugate, it says the conjugate of the complex number z equals r cosine theta plus I sine theta is, you can put z bar on the top like that. That means conjugate. R stays the same, but what happens to the thetas? Become negative. I sine negative theta. That's called complex conjugate of trigonometric complex number. Example in this, if we are asked to find the product of 2 times cosine pi over 3 plus I sine pi over 3 and its conjugate using multiplication in trigonometric form. So we can't use other methods. So to multiply that out, so you take 2 times the cosine pi over 3 plus I sine times pi over 3 times the conjugate of this. R stays the same, but what happened here, the angle changes from positive to negative. I sine negative pi over 3. And to do so, you multiply 2 by 2 is 4, and then when we multiply, we add the angle. So pi over 3 becomes plus negative, like that, plus I sine pi over 3 plus negative pi over 3. Now let's simplify this. What we get, this is cosine 0 plus I sine 0. And that gives us 4 times, cosine 0 is 1 plus 0. The answer is 4. And it's always true, as a note, if z is r cosine theta plus I sine theta, its conjugate, we said r cosine negative theta plus I sine negative theta, always their product, then always their product, z times z bar is going to be always r squared. And that's what we got earlier. We just got 4. Everything inside the parentheses goes away. Now, what other things good to learn here in this section? We have really important theorem. It's called the Moivre's theorem. So this, the Moivre's theorem talks basically about powers of complex numbers. Powers of complex numbers. So if you decide, if you are given, if z equals r cosine theta plus I sine theta, and you try to find, multiply this by itself once, again and again and again, using what we learned today about the theorem of the multiplying 2 complex numbers in trig form, you will find a pattern. That's what de Moivre's found. He found that they found a pattern. So he said, assuming if this is a complex number, in trig form, and let n be a positive integer, then he found out that if you raise both sides to n, what happens? R gets raised to n, and the angles get multiplied by that n. So this was proven using the theorems we introduced in this lesson. And now what this helps us to do is that it helps us to calculate powers of complex numbers. For example, if we are asked to find, let's say, 1 plus I to the 4th power, okay, even if you want to do like 12 power, see, this will make it, I mean, imagine you want to multiply this 12 times. That's going to take a lot of time. But we can use de Moivre's theorem here to help us to find this. So to do so, we let first z equals 1 plus I. And we need to write this in trigonometric form. Write this in trig form. So we need to find r, which is 1 square plus 1 square. That's the square root of 2. and theta, which is tan inverse of 1 over 1. And that's 45 degrees, or pi over 4. So then z can be written as r cosine pi over 4 plus I sine pi over 4. That's the trigonometric form for that complex number. Then we need to find, then we use de Moivre's theorem, then z to the 12, because that's what I'm looking for, is 1 plus I to the 12, is you raise this to the 12th power and multiply the angles by 12. So 12 times pi over 4 plus I sine 12 times pi over 4. What do we get for that? Z to the 12. This is, the way you multiply this, let me show you this. You rewrite this as 1/2, and there's a 12. Cosine, simplify, that's 3 pi, plus I sine 3 pi. And then what we get, z to the 12. This simplifies to 6, 2 to the 6. And 3 pi is the same as you go back to pi. So it's kind of like cosine pi plus I sine pi. That's what 3 pi. Any odd number of pi is pi. So this is the 1 plus I to the 12. That's what z is. 2 to the 6, that's 64. 2 times 2 itself 6 times. Cosine pi is -1 plus I times 0. So that gives us -64. So I don't have to multiply 1 plus I 12 times. But if you happen to do so, you're going to multiply 12 times and you will end up only getting -64. There's not even I in there anymore. No I's anymore. So that's why this is, that's how this is important. Let's look at another example. Let's say we're asked to find -square root of 3 plus I, all raised to the 8th power. Write the answer in standard form, in the a plus bi form. That's the standard form. So how do we do this? First thing, we write, let z equal this. We need to write in trig form. We find r, which is the square root of the first number square, plus I means 1i, so 1 square. Don't forget the 1. That's 3 plus 1. That gives us the square root of 4, which comes out to be 2. So now, what do we have to do? We need theta. Theta is tan inverse of y over x, which is 1 over -square root of 3. What is the angle that gives us tangent -1 over square root of 3? That's 150 degrees. So z now in trigonometric form is 2 times cosine 150 plus I sine 150. You can do it in degrees or radians. So I did the first one with the degrees. Radians. I can do it in degrees this time. Now we are required to find z to the 8th power. So that would be 2 to the 8th cosine 8 times 150 plus I sine by de Moivre's theorem 8 times 150. So now what we get here, 2 to the 8th, if you simplify it, that's 256 cosine, multiply 150 times 8, that's 1200 plus I sine 1200. Keep this the same. Now, how do we handle 1200? Well, you want to see how many multiples of 360 is 1200. So basically divided by 360. These cancel out. And then you can see that this is 3 copies, remainder 120. So there, you can go 363 times and that will leave 120. So that would be the same as cosine 120. I sine 120. Keep this the same. What's the cosine 120? That's 1/2. -1/2. Plus I sine 120 is the square root of 3 over 2. Multiply now by 256. So 128 plus 128i square root of 3. So with this French mathematician's theorem, it helps us a lot to save a lot of work on multiplying numbers over and over again, those complex numbers. So that's what this section is about. It's about how do we multiply complex numbers and divide them using trigonometric forms. And then we use that to get two things. One is called the complex conjugate of complex numbers, and the other one using De Moivre's theorem to help us calculate the powers of complex numbers.